Let me introduce the breadth-first search. So the step one is that initialize all the vertices except the source vertex. So you are going to paint all the vertices except the source vertex as white color, and the distance to reach to each vertex except the source vertex is infinity, and the predecessor of each vertex except the source vertex is a nil. That is the initial condition. Then what's about the source vertex? The source vertex is initialized using the same three parameters. The color of the source vertex is gray, but if you think about the color of other vertices, initially it's painted with the white color. But the color of the source vertex is painted with the gray color. The distance to reach to your source vertex is 0, because you are going to start the searching process or the traversal process from source vertex, that's why 0. And the predecessor to the source vertex is nil, because we are going to start from the S, there is no, the previous node exists, so that's a predecessor value which is nil. So three parameters are used to initialize the source vertex along with every other vertices. Now the next, I can say that the step 1, this is step 1, this is your step 2, this is step 2, step number 2, that is initializations to source vertex. The step number 3 is we are going to add the source vertex to the queue. So here we have added the source vertex to the queue, and we know that 0 is the distance to reach to your source vertex. Then the step number 4 is a loop. Step number 4 is a loop. What the step number 4 is that just check that whether queue is empty or not. If the queue is not empty, then do the sum operations. What the operations? You have to dequeue from your given queue. Dequeue means you have to delete the element from the queue. If you just think about in this example, your the first vertex that will dequeued, that is your source vertex. The source vertex is dequeued and it is stored in your variable u. Then find the adjacent of your u, and every adjacent vertex is stored in your variable called the v. Then that adjacent vertex color is checked. If it is white, then do three operations. What are the three operations? Same three parameters. Change the color to gray. Find the distance value of your currently discovered adjacent vertex. That is your value of u plus 1. And the predecessor v is assigned to your u. The three parameters will be processed provided the current adjacent vertex v is having the color white. Otherwise, you do not process. If this condition is failed, then what will happen? Immediately you change the color of u to black, because we are not able to find one adjacent vertex which color is white. Whenever there is no more adjacent vertex with white color, your color of u is changed to black. That is the algorithm behind your breadth-first search. Example where this algorithm will be applied. Let me discuss about one example.
Example of breadth-first search algorithm. So you know that we need to pass one graph as input to the BFS algorithm. So let me draw one graph. Suppose we are having vertex 1 which is connected to vertex 2, and vertex 2 is connected to your vertex 3, and vertex 3 is, let's say, connected to your vertex number 4, and vertex number 4 is also connected to vertex 1, and there is one more vertex, let's say, that is your v5, which is connected to v4 as well as your v3. So this graph is clearly visible. So what you can do here, so you know that as per your BFS algorithm, we need to first paint all the vertices except the source vertex. Let's say that your source vertex is your v1. Now every other vertices except your source vertex will be painted with white color. So I am writing W. You just imagine that the vertex v2 is painted with the white color, v3 is painted with white color, and v4 is painted with the white color. So I am writing W to indicate that it is painted with the white color. And the parent of V2, the V3, the V4, they are all nil, so I am not writing anything. Apart from that, the distance to reach your other vertices except your source vertex are infinity. So I am writing infinity, 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 and here is also infinity, and the V5 is also value to each vertex except your source vertex is infinity. We have written that way. Here is infinity, here is infinity, here is infinity, and here is also infinity. So this is the way we have initialized the parameters to all the vertices except your source vertex. Now the source vertex will be initialized. So which way we are going to initialize? As per the algorithm, it will be painted with the gray color, and the distance value is 0, and the parent is nil. So nil, I am not writing anything. So this is the way we have initialized all the vertices. The next step is that we are going to add your source vertex to the queue. Let's say that here is the queue. I am going to add the source vertex. The name of source vertex is P1, which is added. Then you have to repeat until the queue is empty. So we have to dequeue. So whatever the value that you will dequeue as per the algorithm, if you are going to dequeue from your given queue, then the value will be stored in your U. So which one is dequeued? So your U contains initially, let me write here B1. Now find the adjacent of U and store in the B. So U is here B1. So adjacent of V1, I can write your V2 as well as I can write your B4. So the first adjacent vertex, let me write here V2. So we got the adjacent vertex V2. So now the V2 is stored in your V. Then check whether color of V is white or not. What is the color of V2? White. So we have to apply the processing over the V2 what? Immediately change the color to gray and assign the parent value or the predecessor value is your V1. U will become your predecessor V. So V is V2, V2's predecessor is V1. So I made the double line to indicate that there is a predecessor relationship. And what is the value to reach to your V2 from the predecessor V1? That is predecessor value 0 plus 1. So I can write that it becomes 1. So this is the way we have changed the value of your V2 after making some operation. So this is the way we have finished the first adjacent vertex V2. Then you find another adjacent vertex of U V1. Another vertex of your V1 is your V4. So check the color of V4. Is it white? Yes. If it is white, then change the color to gray and assign the parent is the predecessor V1. You will be the predecessor, and the value of your V4 is what? The predecessor value 0 plus 1 becomes 1. Now we have processed the two adjacent vertices. Then you add the two adjacent vertices. So first you added V2, then you have added V4. Now you have to repeat the same thing. Is your queue empty? No. So dequeue. If you are going to dequeue, so which will be dequeued? V2. So now the next time the V2 will be dequeued. So now U value becomes your V2. So U value becomes V2. Then find the adjacent of your V2. V2 adjacent is V3. Is the color V3 is white? Yes. So now the adjacent vertex is V3. So if it is white, change the color to gray and assign the predecessor is your V2 for your V3. And what is the value of V3 now? Your predecessor value plus 1. 1 plus 1 becomes 2. So add the new adjacent vertex V3. So new adjacent vertex V3 is added. Next, is there any other adjacent vertex of U? U is which one? V2. So V2 adjacent vertex is your V1. But V1 color is gray, it is not white. That's why we immediately change the color of V2 to black. Whenever you are not going to get any white color adjacent vertex, the V2 value will be black. U value will be black. V2 now becomes black. Now, next, is your queue empty? No, if it is not queue empty, then dequeue it. If you are going to dequeue, V4 will dequeue it. So now next time V4 will be dequeued and will store in U. Now adjacent of U means adjacent of your V4. So what is the V4? This is the V4. So now Find the adjacent of V4. Which one is that V4? You can see that V3 is the color of V3 is gray, so we will not process. So you go for another adjacent vertex of your B4. B4 is your B5. So you got the B5 which color is white. So now the next adjacent vertex is your B5. So as the color is white, we will go for the processing. What the processing? Change the color to gray. Assign the predecessor to your U. U is now V4. And what is your V5 how much distance or how much cost you are going to incur to reach to V5? The predecessor value plus 1. Predecessor value is 1. 1 plus 1 becomes your 2. So there is no more infinity. I can write here the value is just 2. There is no issue. Now once you got it, then you have to add that B5 to the queue. So B5 is added. Now, is there another adjacent vertex of V4? Yes, there is a V1 color is gray. So it is not a new adjacent vertex. So that's why the color is immediately changed to black. If you are not going to get new adjacent vertex with white color, then U value becomes black. So it becomes black. Then is your Q empty? No. Let's dequeue it. If you are going to Q, B3 will be dequeued. So B3 is dequeued. Now U contains your V3. V3 is which one? This one. So find the adjacent of V3. So which is adjacent? B5 is adjacent, but its color is not white, so we have discarded. Then another adjacent vertex is B4. Color is black. It is not a new adjacent vertex, so discarded. Then another adjacent vertex B3 is B2, but the color is black. So no more adjacent vertex found for your V3. That's why if you are not going to get the white color adjacent vertex, it will be painted as your black. So after painting the black color, the next is your queue empty? No, my queue is not empty. Then dequeue it. So if you are going to dequeue it, so it will be dequeued. So the B5 will be dequeued. B5 is dequeued. So find the adjacent of B5. Which is the adjacent of B5? The adjacent of B5 is your B4, but the color is black, so it will not process. Find the adjacent V5, another adjacent vertex V5, B3, but the color is black. So there is no more white color adjacent vertex found for your V5. So V5 color is changed to your gray to black. Now you just look at the queue is empty, so algorithm is terminated. Now your breadth first search is done in this way. So the result, I can say the result is for breadth first search. First it move to V1, then we will go to your V2, then you will move to your V4, then your V3, then you will move to your V5. So this is the way you are going to search the graph using the breadth first search approach.